In this box are some PCBs that I received from a popular overseas PCB manufacturing house. Now, I wanted to point out that this video is not sponsored, and in fact the PCBs you see in this video, as well as all of the components you'll see me install, were purchased by myself personally. With that out of the way, let's take a look inside and see what I ordered. Now, as is typical with these overseas PCB manufacturers, I received 5 duplicate copies of this PCB, but I'm only going to need one for this project. So let's slip that PCB out and take a closer look. Now, this PCB provides memory and I/O expansion for the ET-3400 Microcomputer Learning System by Heathkit. I recently acquired a ET-3400, but while those are available on this side of the pond, the expansion unit, the ETA-3400, is very rare, and I haven't actually seen one come up for sale, and even when they do in the US, they are very expensive. So I decided I was going to settle on this recreation created by Dr. Scott M. Baker. You can see his website just here, and this is the ETA-3400 Memory and I expansion unit board, and this is a modern reproduction recreation with a few different circuit design decisions. However, it is entirely compatible with the original. Now, as you can see, there are a variety of ICs and different components that we need to install in the board, and I've actually already gone ahead and assembled a kit of components that I'm going to need to install. There are a variety of ICs, and I've provided sockets for those as well, and I ordered each of these chips from AliExpress, and I've just put them together in a little packet here. Likewise, we're going to need some passive components to support the functionality on the board, and some resistors, some capacitors, a couple of diodes, and so forth, just to provide the various signaling and smoothing for the chips. And we'll also need some hardware, including the serial port itself, a power jack, and a variety of different pin headers, and these will provide the connectivity to the board that we will need. Now, one of the neat features about Dr. Baker's recreation is that he's added a functionality for a Raspberry Pi to be attached, and actually you put it face down here, and you see Pi upside down. And this allows you to use this rather than as a serial terminal here. It can provide the serial signals to the Raspberry Pi, and that allows you to plug a keyboard and display directly into that. And so for that purpose, I've also gone ahead and purchased an additional Raspberry Pi that I might choose to install as well. And so this is a Raspberry Pi 02W, which provides both the HDMI port and the USB for the keyboard, but it's also wireless, so it would allow me to connect remotely as well to the ET-3400 once this has all been configured and set up. So what I'm going to do here is I need to go ahead and assemble this. Now, Dr. Baker does sell these boards on eBay if you choose to buy directly from him. However, at the time of order and at the time of making this video, there weren't any available on his eBay store. Now, I'll provide a link to that if you'd like to purchase directly from him, and I think that's probably a good thing to do if you can do so. Of course, shipping it to the UK means that it would have been cost prohibitive anyway to do so. So in this case, it did make sense for me to purchase this directly from the gerbers that he kindly provides on the GitHub, and again, I'll provide links to that as well. Now, there are some documentation available on the GitHub for assembling this, and he also has an interesting video. Again, I will link in the description. But the details on assembly are a little bit scant, to be honest. You really do need to know a little bit about what you're doing. I have printed out the documentation he does provide, and that does include a layout, which includes where all the components go, so that's very nice. He includes the schematic that you need, and of course, he includes a bill of materials, which is where I use to assemble my components here. So hopefully I've managed to put everything I require together. So I'm going to refer to these throughout the assembly as my reference, but there's no Heathkit style guide if that's what you were looking for. Again, with all that out of the way, let's go ahead and begin our assembly. Now, as usual, I am going to start with the resistors in my assembly. So let's have a look inside here and see what we've got and see where we might go ahead and put those. So we have a variety of different resistors on the bill of materials, and they start down here. We have 100k resistors, and we need 3 of those. And if I look carefully, maybe I can see them. I think these are our 100k resistors. So there we go. We're going to need 4 1k resistors. So hopefully that is these ones here. Yeah, I think these will be my 1k resistors. Turn the sheet over. We need 4 10k resistors. I think these are my 10Ks. We need 1 3.3K. This is our 3.3. 7 150 ohm resistors. So hopefully I have all of those here. And I missed out the 1 100 ohm resistor as well here, that is just here as well. So that's just there. You can see I've already got the diodes out that we're going to need as well, and those are on the other side of the sheet, just here, D1 and D2, so 2 diodes. So let's go ahead and install these fairly low-level through-hole components. We can look to the layout diagram here so we can see exactly where all those components need to go, and of course we can cross-reference the silk screen that's on the board with the bill of materials. Now I think this is quite handy here because some of the silk screen on the board is a little hard to read, where some of the text does overlap with some of the other outlines of the resistors. So I think this will be quite handy to refer to. Although I said I would start with resistors, I think I'm going to start with these diodes just because they're on their own, just a pair of them, and we'll get those out of the way. And they go just here. Now, as usual with diodes, we have to make sure the band goes to the band on the PCB. And so let's turn on the soldering iron and make sure that's heating up. Okay, diodes out of the way. Let's go ahead and install our 150 ohm resistors. There are 7 of them, and they should all go along just here. So 1, 2, 3, 4, 5, 6, 7. So that should be all of them. And we can see our 150 ohm resistors. And let's see if we can see the color banding here for you. So here we have brown, green, and brown. So that's 1, 5, and 1, 0. So that's 150 ohms. Next, let's do R10, which is a 1K resistor. These are our 1K resistors. So we have brown, black, and red. So 1, 0, and 2 zeros for 1000 or 1K. Next along, we have a capacitor, but then we have 2 resistors here, 10K, 100K. Here are our 10Ks, in this case, brown, black, and orange for 1, 0, and 3 zeros. Our 100K, this is brown, black, and yellow for 1, 0, and 4 zeros, so 100K. Another 1K resistor, and a 3.3K resistor. So this is a 3.3K resistor, so orange 3, 3, and then a red band for 2 additional zeros, giving us 3.3K. While we're here, let's do this R4 as well. And again, we can see R4 here, it's another 1K resistor. And of course, anytime we could refer to our bill of material sheet instead. And again, R4 is a 1K resistor. Now, we do have a few more resistors to go, so let's go ahead and install those as well. We have a 10K just here, which is R20. You can see that this actual layout here is actually from version 0.9 of the board, and if you look closely, you can see we actually have version 0.10, so 0.10 of the board. And so this is a slightly later version, but the illustration diagrams haven't been updated, but in this case, we have R20, and R20 is just moved very slightly, so we need to put it here. And that's our 10K resistor on this diagram. And again, cross-referencing with our bill of materials, we can see again, our R20 is a 10K resistor. We also have a group of resistors here. And here we can see we have a 10K, a 100 ohm, and 100K. So let's put these in order. Then we have our 100 ohm resistor. And you can see that here, this is brown, black, brown. So 1, 0, and 1, 0, or 100. then 100k, another 10k, and our 1k. We have one more resistor left, and this one just goes here. It's a 100k that goes above the diodes. Okay, so that's all of the resistors and diodes. If you look carefully, you'll see there's actually what's looked as another resistor just down here, R21, and it's got a 0 next to it. And that's because if we check the bill of materials here, we can see R21 is a 0 jumper, and a chunk of wire will do. So I'm going to grab one of these leads I've cut off, and I'm going to use that. So next up, I think I'm going to do the capacitors, which is some more of these components in here. But actually, before we do that, there's also this component here, and this is actually a resistor network. So it's really just more resistors. So let's sweep all this out of the way. So this is a resistor network, and it should be a 2.2K resistor network. It actually has 7 pins. It provides 6 resistors, and they're all connected at one point. Now, this provides some pull-up functionality here for these jumpers. We can see that here in the schematic. So here is our resistor network, and it pulls up on all of these jumpers here that go into IC number 3, which is our 6821 PIA. Now, as you can see, they're all connected in position here on pin 1, and that goes in our case up to 5 volts. So with any other device of this type, there is a dot, which hopefully you'll be able to make out in the video, on one end, and that's on the left hand side here if you can't. So that dot is pin 1. And on our PCB, there should be a pin 1 marker, and indeed there is just here. A little hard to see, but again, of course, we can compare with our diagram here. And so if I put this round the same way, see what all the resistors are, we can see our pin 1 is just here. And that means that our dot on our resistor network needs to go that way round. Okay, they're all connected. Now, as you might have seen, I accidentally flooded this pin here, so I'm just going to see if I can wick that away to make it easier to install the jumpers when we get to that point. And there we go, I've now cleared that hole as well, so that's good. Okay, as I mentioned, I think I'm next going to do some of my capacitors, and we'll see how those go. So there's quite a few of those as well. We have some different ones. We have electrolytic here. So next we have to look at all of these other capacitors here, and there's a good variety. They look very similar, so I've gone ahead and I've actually put this piece of paper around one so I can make sure I recognize it. And then I have one longer one here in this cardboard piece, and then I should have, I believe, 11, and yes I do, 11 of these 104 capacitors. So we can see those down the list here. We have our C1, which is 0.047 microfarad. It's this one here, which is marked 473. It's very small writing, so we'll see if we can see that on here. Yeah, hopefully you can see 473. We then need a 2.2 microfarad, and that should be this capacitor here, marked with 225. We have a 0.047 microfarad, 472. That one's quite clear. This one's not of the exact same type. Didn't have one available. And then, as I mentioned, we have 11 0.1 microfarads, and these are here. And these are all marked 104. Hopefully you can make that out. Okay, so since I had a little confusion there with this one, and it looks very similar, let's do this 473 capacitor first. Now, these capacitors aren't the right leg width, so I'm going to have to adjust them on the fly to try and bring them in very slightly. Okay, not perfect. Let's do the other unique capacitors next. So we have the 225, and we know that's our 2.2 microfarads here, and that goes in C2. Let's look on this diagram here for our C2. And we can see it just here in between our resistors. In this case, you'll see there are 3 holes, and I think this is because the designer has allowed us to use these wider legged capacitors that I actually have, so they'll fit more neatly in the board, just like so, nice and flush. That's very neat. So what I'm going to do is just grab a multimeter to show that these 2 lower connections are indeed connected together. So here's the multimeter. I'm just going to pop it into diode and continuity mode. And there we go, we get a nice beep. And if we look here, these 2 connections, the 2 left connections, should be connected together. And there you go, they're connected together, but of course they're not connected to the other pad, or at least not directly. They're maybe going through some of these resistors. But these 2 at the bottom are both connected together, and that's because I believe they're both on the ground plane of the board, so that's quite convenient for us. Now we have our 472 capacitor, the one that I had in the cardboard. So now we just have to fit all of these other ceramic capacitors on the board, and we'll pop those in place now. Again, this is going to be a little bit of a pain because I have the wider spaced capacitors here that I need to pop into place. I do have some cheaper, lower quality capacitors that don't read so well, so let's go and have a look at those maybe before we go ahead and spend time bending all of these legs to the correct shapes. So here's my component tester, and here are my other capacitors. Now these ones I believe have narrower legs. Let's have a little look. So you can see the leg spacing is much narrower, and so they would fit better in this board. So let's just show you for an example. And these are still 104 capacitors, just as before. Now the problem is, previously I've had pretty poor readings on these, and so I've tended to avoid using them. So let's pop these in this tester just to show you what I mean, and let's see if it proves me wrong. So you can see here, this is coming out at 46.99, so less than half its rated capacitance. I've got these ones here, which I assume are better quality, but I haven't actually tried them, so let's see how these ones work out. And here you go, this one is showing up at 105. Now, although these are only there to smooth the ICs, provide very close decoupling capacitors for the ICs, in most cases, I think it's important that we use the correct ones. Partly because around this IC here, they're being used for a charge pump. That means that the serial port here is going to provide the correct nominal voltages. These decoupling ones here, again, potentially we could use these ones, but if I'm going to spend time bending the legs to make sure that we have the correct rated capacitors around the serial port driver chip here, then I might as well do them all in the same style. Pop these ones back in the parts bin for a less demanding project. Okay, so I've bent all my capacitors, some better than others, but I think that's not too bad. So hopefully you can see what I've done here is just to adjust the leg spacing slightly. Okay, so I need to go ahead and install all of these all across the board. So I'm going to start around the IC here. Okay, so that's all our capacitors in as well now, with of course the exception of that last electrolytic. So now I suppose it's time to get some of this hardware installed. We have the pin headers, but we also have the sockets. And I think the sockets are in the middle of the board, so I think I'm going to go ahead and do those next. I'm not going to install the ICs at this point because we want to keep them safe. So they're actually on some anti-static foam here, although of course these came from AliExpress, and so many of them weren't in anti-static foam at the time, but always good practice if you have some available. Now the sockets have a small indentation just here, and that should line up with the indentation on the board. So I've just done 2 pins on each socket, and then we can remove the blue tack and make sure to see if our sockets are as flat as they could be, or if they're slightly proud. If they are, we can of course adjust. And actually this one does look a bit like it's got a bit of give in it. So we're just going to use some pressure on the other side, gentle pressure. There we go. Just need to finish up soldering all the remaining pins. Okay, so all our sockets are now installed. You may have noticed that I had a bit of trouble with this socket just here because I had managed to fill another hole again on the PCB, and so I couldn't get the leg through. I think this knife tip here is probably a little bit chunky for this kind of board. There's a lot of very close components and a lot of close contact soldering joints, so I think a more usual conical tip that I usually use would have been easier to control on this board. However, I hadn't switched it back out again from a previous project. I've just noticed where there is an outline for a capacitor here, which I don't think is on the original design. No, there's a space here. So I think this might actually be some new contact pads for that capacitor. So let's have a little look and see if they are indeed connected to where we expect them to be. Again, another job for the multimeter. Back to continuity. Perfect. And so we would expect the positive to be connected to the plus 5 volts, which is here, and the ground to be connected to this position here. So let's try that out. There we go. And ground, which is here, and also this pad here. So actually, Dr. Baker has updated the design to allow us to actually install this capacitor in the right place. So I think I'm actually going to do that now. Right. Now we just have the rest of our hardware to install, and the things that are going to be particularly troublesome are things that stack. So in this case, we have two cassette outputs here that we might use, and so I'm actually going to do those next because I prepared some jumpers when I made up my little pack here. You can see here that I have two sets of 4 jumper pins, and these are designed to go here. Now I could put these either way round. In fact, I think in his design, the original designer has them this way round, hovering over these resistors, but I'm not particularly comfortable with how close they might be. So I might have them facing outwards instead, like so. So I'd put the lower ones here like this, and then put these ones, which was originally a double stacked header anyway, but I've just modified it slightly so I can put it like so. And so there should be enough clearance here should I decide to switch between the two options. Now these two versions basically provide different voltages to the different headers. Okay, because I modified these, they are at a slightly longer level here. So I'm just going to nip off the back ends. Next up, we should probably put in a few of these jumpers that are positioned all over the board. So what I'm going to do here is probably start with the ones that are problematic in the center. Now I didn't pre-trim down these jumpers into any particular sizes, so I just have a selection here. The exception, of course, being these long ones, both 20 pins here, both 20 pins here, and the 2 sockets as well. These are all for making various connections to the board, but the smaller sets here are just for wherever they need to go. I do have one more right angle header, and that's actually for this connection up here. So yeah, let's put this one in next, just to get that one out of the way as well. So let's do this middle one here with 3 pin positions. So this one has 7 on it, so if I cut this one, I'll have a set of 4 as well. And I'm just going to use the nippers here in between to carefully try and snip them So let's put this triple header block in the center here. Okay, I think that's pretty good. I probably should have put that in before the socket, but it's in there now and it is flat. You saw I used the tweezers there just to make sure it was being pushed against the board. Okay, jumper 2 here is 2 sets of 6 headers. So what I'm going to do is I'm going to take these sets of 8 that I've got here and just nip off the last 2. Just going to use these pieces here to hold them together at the correct distance while I'm soldering these in. Okay, again there you probably saw I had a little bridge there that I had to remove with this solder sucker. And again, the curse of the oversized chip strikes again. I'm not going to change it at this point, but I probably should have done. Okay, so there's a pair of jumpers here, so let's pop these in as well. Okay, so there's a set of 3 needed there. Another block of 4 down here that we can put in. Okay, and another 2 here, and another 2 here. So again, let's get this tricky one next to the capacitor next. Again, another case where I probably should have popped it in before the capacitor. Okay, and last one goes here, and this allows it to provide power to the Raspberry Pi from the board itself. Again, in the original design, he actually has a right-angle one here. I don't really think that's necessary in this case. Maybe I'll live to regret that decision. Okay, so that's all of our loose pin headers now attached, I think. So the next things to do are a socket for the Raspberry Pi, the serial port, and the connection to the ET-3400. Okay, so that connector is now done. Now, the socket for the Raspberry Pi is a socket rather than pins, because typically Raspberry Pis have pins on them. Now, because of the way the ICs will sit in here, the original designer uses wire wrap sockets and has them sitting actually slightly proud. Now, I don't actually have any of those, so I'm going to go ahead and use these flat ones that I do have here and install these. But to avoid any issues, what I'm going to do is then use longer extended pin headers on the Raspberry Pi, which I think will be perfectly fine in this instance. And of course, that will mean that it will sit a little bit higher, as it should do, to avoid sitting on these chips. Now, as I say, I'm not sure how much I'm going to be using that. I may end up going back and replacing this with some wire wrap sockets if I have the opportunity in future. But for now, I am just going to pop some of these headers across just to, again, keep them at the appropriate distance. Okay, so there we go. That's my make to do socket. And as you can see, the pin headers I'm putting in the Raspberry Pi will keep it reasonably high off the board. In fact, let's pop both of these in here right now. And we can take our Raspberry Pi, and hopefully that will give us enough clearance over the IC here to still get a HDMI and keyboard or USB cable for the keyboard in as well. Now we won't need the power because of course we can choose to power it via this jumper here, which will give us the opportunity to power the device. I'm not going to solder this right now, I don't think. What I'm going to do next is this part here. So we have two more things to do other than the Raspberry Pi itself. We have this power jack, which goes in here. Now, again, this is optional because the board can take its power through this input position cable here. So we have a ribbon cable that goes to the ET-3400. We can take power via that, but you can power it independently if you choose to do so with a 5-volt supply. So I'm going to install that socket as well. So I'll install that first, and then we'll finally have the serial port as well that needs to go in. Okay, so that was one connection where having the larger tip was really quite beneficial. It allowed me to flow oodles of solder into those connections to make sure they're nice and strong. As I say, the last connector to install is this one here. So this is a female serial 25-pin serial port, and that is what's specified in the original. So that's what we're installing here. I'm going to use an adapter actually so that I can connect this to my computer as a serial terminal, or any other serial terminal for that matter, but this is what was specified originally, so just make sure that's clipped in nice and firmly. These little parts here do indeed clip, so that's quite nice, and then we can just go ahead and solder everything in. But first I'm going to do these end connections to make sure, again, everything is held in place. Right, and before we flood those too much, let's make sure this is nice and flush on the board, which it is. Okay, so that's everything soldered onto this PCB. As I say, these headers are only required for the Raspberry Pi, which I'll probably experiment with in future, so I'm going to pop those to one side for now. Now, the next thing we need to do, of course, is install the chips, and I have all of those right here. Of course, we need to make sure we get them in the right sockets. Now, these are laid out in the diagram here, as well as a listing of the ICs we require. So we can see that we have to install into the IC1 socket a 28C64, and we can see that this is an EEPROM. And so I have the EEPROM here. Into socket number 2, we have the ASC6C62256. So this is just a 62256 SRAM, and so here we have one that I have here. This is the SRAM chip, and that goes into IC socket 2. So let's pop that one in first, actually, and we'll get back to the EEPROM in a bit. So let's just see if we can get this to seat neatly. So while I'm just installing this, I'm just going to mention that the GitHub page has a list of tested SRAMs. This was essentially a random AliExpress purchase, but this one happens to be one that is on the list as a working SRAM. So we'll see if that is indeed the case. Now, this does look like a pull from a previous board. It was quite stiff there to get into the socket. There is some solder on the legs that's been cleaned up to a reasonable standard. Now, there's a 40-pin socket here, of course, so this is for the PIA. I think, again, this one is a pull. It does look like there is some solder on the pins. In this case, there's no dimple here. Well, there's no cutout here, notch. There is a dimple, though, which means this is where we have the pin 1 alignment. Okay, that chip is in as well. We have a couple more ICs here as well. So these ones are 2 different sizes. This one is the Max 202 IC. And this is IC5. And it's the serial driver, and this is the one that requires the charge pump here. So this is a 202, not a 232, which you might have also seen in other examples. This one is specified for a 202. And again, notch to notch on the design here. This one is quite tight to get in, but let's see if we can sneak it in. Next we have IC6, which is a comparator. This is an MC3302, and I have that one here. Push that home as well. There we go. And then we have our last two chips. So I mentioned we have the EEPROM already, and that goes in the left-hand socket, 28C64 EEPROM. And we also have a GAL chip, which is a programmable logic chip. And that goes in this socket here. Now, the key point is that both the EEPROM or EEPROM and the GAL chip are programmable. Now, I've already gone ahead and programmed these, but I will probably have a follow-up video where we can discuss how to do that if you'd like to do that. Of course, you can use one of these popular EEPROM programmers to program these kind of chips, but in my case, I built something out of an Arduino following a couple of different projects online. I'll provide links to both of them in the video description. This is there's a GAL programmer I can use for this, and I'm using a programmer called TommyProm, which is a particularly popular EEPROM programmer for Arduino users that I use to program this. But I'll provide links to both of those, and I'll show you that in a future video. So having actually programmed these already, it's safe for me to put these in. Now, the code that you need to put on both of these is again kindly provided by Dr. Baker in his GitHub repository. So no problems there. You can just program the precompiled code for both of these as required into the individual devices. So there we go. So as I say, the Raspberry Pi itself is optional. That allows us to have a serial terminal out via the Raspberry Pi if properly configured. Again, the instructions for that are in the GitHub. To connect this to the ET-3400, we will use a ribbon cable. But I think this video is probably already quite long enough. So what I'm going to do now is go ahead and test this device off screen. And what I'll do is report back and show you all of its functionality in a future video. But for now, I hope you found the assembly of the ETA-3400 recreation by SM Baker interesting, and I hope to catch you again in the next video.